So chapter 9 is all about circles, and so it starts out with some basic definitions that I know you know, but we're going to learn these other definitions like a tangent, a chord, a secant that you probably don't know. Okay, so first of all, the definition of a circle. So you're probably going to have vocab on this test, right? So the circle is the set of all points in a plane that are equidistant. So equidistant, what do you guys think means? Equal distance, right? From a given point called the center. So it says a circle with center P is called circle P, and the way that we write that, like the symbol for circle, is like a circle with a center in it. So we'd write it as circle P like that. So we read that symbol as circle, so circle P. So the radius, as you know, is the distance from the center to the outside of the circle. And there's an infinite number of radii, right? So radii is the plural form of radius. Congruent circles are two circles with the same radius, right? So if they have the same radius length. And a chord is something that you probably haven't seen before. Okay, so a chord joins any 2 points on a circle with each other. So a chord is a segment whose endpoints are along the circle. Okay, and a diameter is a special type of chord. Okay, so what's special about a diameter? It's halfway through the circle, so it's a chord that goes through what?
The center.
The center, exactly. So if we have the center there, the diameter would go all the way through. So that would be like our center. Okay, and so it ends up being twice the radius. So that distance is d. And I'm sure that you guys know that. All right, so a secant is like a chord, but it's not a segment. So previously, if you guys look at the definition of a chord, we said a segment. A secant is kind of an extension of a chord. It's going to be a line that intersects the circle in exactly 2 points. Okay. And a tangent is kind of like that. It's a line as well, but it's going to intersect the circle in only 1 point. So it's a line in the plane of the circle that intersects the circle in exactly 1 point. So this is cheesy, but I always say a secant slices. So it slices through the circle, and a tangent touches. Do you understand what I mean by that?
Yeah.
Okay, so a secant is the one that slices through the circle. A tangent is the one that just touches the circle at a single point. All right, so we're going to talk about the names of these things. So if you remember, if I have AD, and notice how there's just a little segment line above it, we don't have the arrows on the end of it like this, right? So if we see that, then this is going to be a segment, not a line. So that would be the difference between like a chord and a secant, right? So we're going to look at those things. So if I have AD and it's just this segment right here from point to point, what is it? It's a chord, exactly. How about EG, the line? So notice how there's these line things over it. That means that it not only goes through E and G, but it actually extends past it. In other words, it's going to extend forever past it, right? It is a secant, yep. It's a secant because it slices through, right? So how about AC? Cam, you got this one? AC?
That's radius.
It's a radius. And then AG? Diameter. You got it.
What is it?
A diameter. So was AC the only radius drawn? No, I could have CG, or I could actually connect these, CF. That would also be a radius as well. So there's other radii in there. All right, what do we think the word is if things lie in the same plane? Think way back when to chapter 1. If something lies in the same plane, it's called coplanar. Good. Co means share, so like coworker, right? You share a job with your coworker. So it shares a plane. 2 circles in the same plane can intersect in 1 point, 2 points, or no points. So if 2 circles intersect in 1 point, they are called tangent. If 2 circles do not intersect and they have a common center, they are called concentric. Mathematical spelling bee right here. Concentric circles. Do you know what that is? I draw it all the time on my review games. It's a dartboard. So it looks like this. These are called concentric circles. They share a, do you see the word? Share toe, right? They share a
center.
Concentric circles. Shared center. Oops. So it would be like right there in the middle. All right, so draw the following types of coplanar circles. So can we draw a circle where we have 2 points of intersection? Well, 2 circles where we have 2 points of intersection. Sure, we can see that, right? Something like that. That's 2 points of intersection. How about 1 point of intersection? Can they cross in just a single point? Yeah, they could. Like the top of a snowman, maybe, right? It's like something like that. That would be concentrics, or not concentric, that would be coplanar circles that have 1 point of intersection. What if we did something like, oops, I messed it up. Like that. Would that still intersect in a single point? Yeah, that works. Make sense? How about no points of intersection? Something like that, right? Those have no points of intersection. Does that make sense? So a common tangent. So a common tangent is a line or a segment that is tangent to 2 coplanar circles. So we have things called internal tangents and external tangents. What do you guys think the words internal and external mean? Internal means inside and external means outside, exactly. So looking at these pictures, I think you can, these are not hard for students. Okay, looking at picture A, would you call these tangents, are they internal or are they external?
External.
They're external, they're kind of outside those circles, right? So we say that something is an external tangent if you connect the 2 centers of the circle, and those tangent lines don't cross there. So these are external. But you see on this one, if I join my centers, do you see how the 2 radii, or the 2 centers, if I connect them with that segment, these tangents cross it? That would be an internal tangent. Do you guys see why we would call it internal? Because they're inside those circles, right? So what do we think on the next one? External or internal? External. It's on the outside. Okay? All right, so internal and external, again, inside and outside. So the internal of a circle is the points that are inside of the circle, and the exterior of a circle is the points that are on the outside of the circle. So given the center and radius, give the center and radius of each circle, describe all common tangents. So let's talk about circle A. Remember how we write circle A? Our little circle symbol and then A. Can you guys count the length of the radius, and can you find the point that is the center? So our center is what point? We go over 1, 2, 3, 4, 5. Nope, 5. Then we go up how many? 1, 2, 3. Yep. So it looks like 5, 3. Can we call it that?
Yeah.
All right. What's my radius?
Oh, it'd just be 4.
I think it's 3, isn't it?
4.
3. 1, 2, 3. Count the bumps, not the lines.
Oh, never mind. I was counting B. Or C. My bad.
Okay. So how about circle B? So circle B is at center 0, 1, 2, 3. Radius? 2? Yep, good. How about circle C? Our center looks like it's 5, 1, 2, 3, 4. 5, -4. Do you guys have that? What's its radius? 4. As a little preview to a section at the end of this chapter, and also something that's in Algebra 2. So let's see if you guys are smart enough for this Algebra 2 stuff. going into it next year, right? So if I have something in Algebra 2, the way I would write the equation of the circle is I would write x minus 5 squared plus y plus 4 squared equals 16. You don't have to write this, just kind of watch what I'm doing. So like this one would be x minus 0 squared plus y minus 3 squared equals 4. Does anybody see the pattern? Rhett, you're not allowed to answer. He's already trying to raise his hand. He's taking Algebra 2 this year. Anybody else? Yeah, what do you think, Charlie? Yeah, it was this thing squared, right? Gave 4, and this thing squared gave 16. I agree with that. Everything, though? So what would this other one be? Circle A. What do you think? X minus squared plus squared equals 3 equals 9. Yeah, do you guys see it? It's always in the form x minus, we call it h. X minus h squared plus y minus k squared equals r squared. And it has to do with the distance formula. Okay, do you know how the distance formula was like x minus x1 squared plus y minus y1 squared equals d squared, right? And we took the square root of it to get the d by itself. That's where it comes from. Because it's saying every point along the curve is the same distance, right? That radius. It's the same distance from that center. So it's like finding the distance for every single one of those points. So it's kind of a little preview of what we're going to do eventually. All right, so let's look at this next theorem. So it says, if a line is tangent to a circle, then it's perpendicular to the radius drawn at the point of tangency. So this is another important thing about tangents. So every time you hear the word tangent, you should say tangents touch, right? So tangents are going to touch the circle in exactly one point. Okay, that's what we hear every single time we see tangent. You know what else I think of with a tangent? Put your hands like this. Like a timeout, like a ref says timeout, or not a ref, I don't know who would say it. Someone on the team says timeout, ref, right? We have perpendicular lines as well. Okay, so this tangent is going to be perpendicular to the radius. So there's going to be this little 90-degree angle in here. So if a line is tangent to a circle, then it's going to be perpendicular to the radius drawn at the point of tangency. What do you guys think the point of tangency is?
Where they like cross.
Yeah, like where it's touching that circle. Because remember, it touches in a single point. That's what it is, the point of tangency. Right? So going backwards. So it says if you have something that is perpendicular, so if you get that that's 90 degrees and you're like, oh, that's a 90-degree angle, then what do we know? That line has to be tangent. So it's the same going backwards. Do you guys remember what that's called from the beginning of the year? Started with a C, when we can flip an if-then statement and flip it around. It's called the converse. So the converse is true as well. Okay, so here we go. So number 1, is EF tangent to circle D? So I don't know. We want to know if EF just touches this in a single point or if it's going to intersect again. I don't know. Based on the drawing, it looks like maybe it is, but how can I see if this is a 90-degree angle right here? Usual Joseph, how do I decide if this is a 90-degree angle or not? How did we do that before? How did we decide if something was a right triangle? What theorem? Got nothing? Oh my gosh. Pythagorean theorem. We're going to use the Pythagorean theorem and we're going to see if it's true. So we're going to do 8 squared plus 24 squared equals 25 squared. Colin, what you doing back there? You good?
Yep.
We want to see if this is true. So if I don't know if something's true, a lot of times I'll write like a little question mark over that equal sign. I'm like, I don't know, is this true? And then we find these numbers. So 8 squared is 64. And 24 squared is 576. I want to see if that's equal to 25 squared, which is 625. So do they add up? 64 plus 576 is 640. Is 640 equal to 625?
No.
No. So what did we say? No, this isn't tangent, right? So not tangent. All right, and then we try it on the next one. So we say, well, is 11 squared plus 60 squared, is that equal to 61 squared? So we do 11 squared, we get 121. 60 squared is 3,600. And if I do 61 squared, I get 3,721. So I'm seeing if this is true. Is it true? I think it is. Because when I add those together, I do get 3,721. So yes, tangent. All right, makes sense? Yeah.
After 24 squared, that's like question mark over.
Yeah, it's like equal sign with a question mark on top of it. Because we're not sure if it's true. We're seeing if it's true. So we just do an equal sign and you can put a little question mark above it. Until you get to the end and you're like, oh yeah, these are equal. All right, let's go the other way. So that's how to verify if we do have a tangent. We just show that we get a 90-degree angle there, okay? So now we want to know, going the opposite way, we want to know that this, or we say that this is tangent. So we're like, oh, BC. Did my little B get cut off? Does yours look okay in your notes? But that's a B. So BC is tangent to D. So what do I write? So every time I hear the word tangent, I think of two things. What are the two things? Tangent lines touch in a single point, right? Tangents touch. What else do I think? Basketball. Timeout. Okay, so when I see the word tangent, what do? I make that little 90-degree angle. Exactly. Okay, is that 60 down there? Mine got cut off. I don't know why.
Yeah, it's 60.
All right, so now I want to find the radius. Well, where's the radius? I could draw the radius in wherever I want. I could draw my radius here. I could draw it here. I could draw it here. Where do I want to draw my radius, though?
Would it be
DC, right? You want to draw right there. That's R. Are we able to find R? Yeah. So we set up our Pythagorean theorem. So we say R squared plus 60 squared equals 65 squared. And we solve it out. Colin, do you have your phone out back there?
what?
Do you have your phone out? Is it behind that giant pencil case? Oh, good. All right, we good?
Yes.
All right, so ice cream cone theorem. We're ready for it? This is my favorite. My teacher called it the ice cream cone theorem. I've never seen this called ice cream cone theorem anywhere, but my teacher called it this, and I remember it. So I'm going to use it, and you guys will remember it. So this is when we have these tangent lines that form an ice cream cone. Do you know what I mean by that? So we have a circle, and we have a tangent line here, and we have a tangent line here. Imagine we used our patty paper, and we folded right across here. What do you think this line and this, so these two segments, what do you think is true about them? They're congruent. Those two are going to be the same. So that's the ice cream cone theorem. So it says if two segments from the same exterior point, so the same point that's outside, this is the exterior point, point S, the same point that's outside the circle, connect and they're tangent to the circle. If they are tangent to the circle, then they have to be congruent. So here's what's happening with this as like a quick proof. You know how you have 90 degrees there? You also have 90 degrees there. Why are my lines all funny? I'm going to try this again. So I connect. This is a 90-degree angle. Why do I know that that's 90 degrees? Because I said they were tangent to that circle, right? So tangents touch. I make that T. All right. PS is a shared side, reflexive property. What do we know about PT and PR? Do you guys see how these are both radii? And we said that this one was a shared one. Do you guys remember way back when we did like side angle, and so on?
Yeah.
This one sadly is angle, side. What makes it okay that it's angle, side? The 90 degrees, which means, oh, we have two of the sides. We could always find that third side with Pythagorean theorem. What did we call that? It was a special form of ASS, yeah. It's hypotenuse leg, right? That works because of hypotenuse leg. So because the two triangles are congruent, then you can say, oh, that means that this part and this part are the same. That's where that comes from. You could go through that whole proof and you would get it. Okay, so basically, if we have a circle and we have tangent lines to the same point on the outside, so if we knew these two lines were tangent, those two lines have to be congruent. So looking at this picture, I know that 5y minus 1 and 4y plus 4, those are tangent lines, right, because we have 90 degrees and 90 degrees, and they go to the same exterior point. So I can say by the ice cream cone theorem that 5y minus 1 equals 4y plus 4, like that. Cam, you good?
Yeah.
And I solve it out. So I get y is equal to 5. Jacob, how about x? What's x going to be? It is 10. Do you guys see it? How do you get that so quickly? Because you knew it was a radius, right? These have to be the same. Although my picture does look like it's a smidge off now that I see it really, really big. All right, how do I get z then? Who's the smarty that can get this? Colin, you did it. Yeah, Pythagorean theorem. Because we know that we have 10 here, and we know z, and then how do we get this other side? We plug in y, right? Y was equal to 5, so this side is 25 minus 1, it's 24. So we have a right triangle in which we have 10, 24, and we want to find z. So we do the Pythagorean theorem. So we say 10 squared plus 24 squared equals z squared. I think we just did one like this. Do you guys remember this Pythagorean triple? We get z squared equals 676, which when we take the square root, do you guys know what we get? Hey, mental math trick. My calculus students couldn't do this the other day. You guys are going to be better when you're in AP Calc, because I'm going to teach you all the mental math stuff now. If you think about what numbers these are between, if you're like, oh my gosh, I don't have my calculator. So I gave my Calc students a test, and I had this, the square root of 676, on their test. And they didn't get it. And I didn't mean to put that on the test. I just thought they could handle it. And then they just were like, I don't know the square root of 676 without my calculator. I'm moving on. And they just left it. Okay, but let's think about it. Yeah, it's between, is it between like 10 and 20, 20 and 30, 30 and 40? What's it between? Oh man, you're good. Because you're saying 25 is 625. Did you guys know that one? If you know some of your squares, you're good. But we at least know it's between 20 and 30, right? It's between 400 and 900. So if you could get it even smaller, that's okay. But think about the numbers. This is not hard, guys. I promise. I know I seem like I'm going on a tangent, but I'm not. That was a Charlie joke. All right, so it has to end in a 6. If something ends in a 6, 20 squared, what's it going to end in? A 0. 21 squared, what's the last number? What's the ones digit? It's going to end in a 1, right? How about 22 squared? What's it going to end in? A 4, right? So you can do 22 times 22. Do you guys know what I'm saying? And you get a 4 right here. You with me? Yeah. 23, what's it end in? 9. 30. 29. No. 28. No. 27. Ends in a 7 times 7 is 9. 6 times 6 is, it could be this one, it could be this one. Is it 26?
It's 25.
Or is it 24? 10 squared plus 24 squared equals, would it equal 24 squared? No, it has to be 26. Could you eliminate all of these based on like the 24 right there? Yeah, you could eliminate all that before that. But you guys are smart. You can figure this out. All right, so anyway, so we get 676, and it does work out nice and evenly. And you could do that off to the side and say 24 times 24, and you would indeed get 676. So even when you don't have your calculator, you don't just cry and say, oh, I don't have my calculator, I don't know how to do this. You can still get it. All right, so the next one. Who can set up my equation for me? Do I have the ice cream cone theorem? What's the ice cream cone theorem say? You guys are dying, man. It's really not that bad. We got 2 more problems, and then you can work on your homework.
Wow.
You got it. And we solve it out. Now, luckily, when I subtract 2x, look, they go away. If they didn't go away, you would get to factor. But I was nice to you. I don't think I put you through that pain on your homework either, but it doesn't mean that I won't in the future. So I get plus or minus 2 when I take the square root, right? Remember when you take a square root, how you write plus or minus? But sometimes negatives don't work, and sometimes positives don't work. It depends on what you had in the problem. So look back through. Can you plug in a 2? 2 times 2 plus 5 is 9. What about the negative 2? Does it work? 2 times negative 2 is negative 4 plus 5?
1.
1. Is that okay to have a length of 1?
Yes.
Yeah, you can have a length of 1. So it is plus or minus 2. Both of them do work. All right, last one. Sometimes you'll see these, and the first time you see them, I used to not have this on the notes. Students are always like, wait, what? What's happening here? So it says, find the perimeter of the quadrilateral that is circumscribed. Circumscribed just means goes around. So it goes around the circle. So we want to find the perimeter of this quadrilateral. So I at least know this whole side is 24, right? And I at least know this whole side is 15, but I don't know these other sides. Brainstorm with me. Help me out here.
Wait.
How do I get these other sides of the quadrilateral? I know this side and I know this side, but I don't know the ones on the right and the left.
Are they equal?
You what? Let's use our ice cream cone theorem. The fave, right? 16. Do you guys see what else has to be 16? Right here. Right? 9. So this also has to be 9. Get how it works?
Yeah.
6 and 6. 8 and 8.
So they like kind of mirror each other, but not
Totally. So we end up getting 8 plus 16 plus 16 plus 9 plus 9 plus 6 plus 6 plus 8. And we add all that together. $78, did we get that? Centimeters? That's it. Make sense? Okay. I'm going to pass out your homework.